When the topic of reverse engineering is being discussed, it can seem like the focus is most often on parametric designs for solely engineering-focused applications. But what about a part that doesn't fit that traditional workflow? Two of the main applications that can break the mold are dumb solid parts and organic models. Dumb solid parts are for projects that just need to be accurate to form, but the underlying structure of the model doesn't really need all the bells and whistles gained by being built parametrically. Organic shapes can be extremely difficult to define with a parametric modality. Both of these can be handled much more easily with a more direct modeling approach. Geomagic Wrap offers a unique set of surfacing tools that allow for a surprising level of control in the sometimes scary world of non-parametric and organic 3D modeling. The start of almost every surfacing project begins with running the AutoSurface command. As its name suggests, it automatically surfaces any scan data as a solid or surface body that it's given, guiding the tool with some basic input information like part geometry, desired accuracy, etc. helps to generate more desirable results. After running the command, the STL mesh model has been translated into a NURBS-based step file format. Extremely fast compared to a parametric workflow, but what if the automatic results need to be tweaked? If changing the distribution, size, or shape of the surfacing patch results is necessary, Wrap allows for the peeling back of the layers of the AutoSurface process, allowing for any edits that may be needed. Working backwards from the output from the AutoSurface tool result, the final NURBS-based surface can be removed to reveal the underlying grid structure. Next, grids can be rolled back to see the patches. Finally, removing the patches shows the underlying contours and panels. Now that the model is back to square one, it can be rebuilt starting with the Extract Contours command. This tool works by dividing the geometry into different sections called panels. The purpose of these panels is to break the geometry into areas of similar curvature, which will yield better results when generating surfaces later on. The process by which these panels are generated is through the extraction of contour curves. These contours are the transitional boundaries across the surface curvature where one distinct area of curvature ends and another begins. By running the Extract Contour command, the system shows how it wants to break up the part given the user inputs. If necessary to edit any contours, users can manually select the appropriate mesh and rerun the command to see the new contour lines created. Once the contours and panels have been built, the next step is to create patches. A patch is an approximately equilateral four-sided subdivision of a panel. Patches are often different sizes and shapes within the same panel. If needed, patch groups can be edited or shuffled to better match part geometry in certain areas if default settings weren't sufficient for the entire part surface. After the patch network is satisfactory, it's time to fill those patches with grids. A grid is a set of more or less perpendicular lines that are placed into each patch. These grid lines are used in the final surface fitting calculations to guide the NURBS surfaces as they are being generated on top of the mesh data. This step is a great final check for any wrinkles in the underlying grid system, which can be smoothed back in line by again reversing the surfacing process to the offending setup step. Finally, with grids made, it's time to generate the NURBS surfaces. At this point, all of the heavy lifting is done, and all that's needed is to feed the grids to the surface fitting function. After fitting, the deviation analysis check can be run to view fitting results. As always, if a result is not desirable, users can jump backwards in the process to fix the issue earlier in the workflow. With Geomagic Wrap, the name of the game is control when it comes to surfacing. Wrap has the automated tools to get you a model as quickly as possible, as well as the ability to manually check under the hood and make critical tweaks when a project demands it. Either way, Geomagic Wrap has the tool set to get any 3D scan into a step model, regardless of organic complexity.